A little bit more filled out in here, but I'm going to lead you through this. Recall that a function is a relationship between two variables in which no input values are repeated. So basically, it passes the vertical line test. We've known this for a long time. But now to talk about the inverse of a function, okay, the operation that will undo, like we talked about on the front side, we have to talk about a function to have an inverse being what we call one-to-one. So again, in order for a function to actually have an inverse, it must be a one-to-one function, which means actually no repeated output, okay? So again, think about this. If a function has no repeated input, so let me get you a little graph. Like we would say a parabola is a function. It has no repeated input, but it does have repeated output. Like these two right here are repeated values of output. So we would need something like the cubic function here. It is a function, vertical line test, and it's also has an inverse that's a function. That's how that kind of goes, and I'll talk more about that in class. But fill this out here and realize that to be one-to-one, we have to pass the horizontal line test. Now be very careful here, okay? A circle, okay, if you look at this, you're like, oh, actually, let's not do a circle. Let's do this one. Horizontal parabola, something that kind of looks like this. You might say that, yeah, it passes the horizontal line test, but it doesn't pass the vertical line test. So our definition is already talking about a function. So that's what I mean by this. If you have a function, it has to pass the horizontal line test. If you have a function that passes the horizontal line test, that's going to be one-to-one. All right, so a few things to know. Basically, how do you find the inverse? The inverse of any relationship is found by, we can just, like we talked about on the front side, we can switch the x and y values. That's what we can do here. Now I'm going to take you back to this front page. Remember, over here, look at this. We have what? 2, 8, like 2, 8. If we now put in an 8 and get out of 2, we're just switching the x and the y values. That's all we're doing, and that's how that relationship exists. Okay? So moving along here, another thing to realize, let me take it, is that the domain of the function is going to turn into what? It turns into the range of the inverse. And likewise, the range of the function turns into the domain of the inverse. And once you get this whole kind of switching x's and y's concept, that makes sense. And on this page, that makes sense as well. Like, look at this. We've got ourselves what? We've got domain of function. What does that match with? Range of inverse. And then we've got range of function matching with domain of inverse because of the concept of you put something in here, you get something out. That output is now the input, and it gets you back to where you started. So that should all connect together with inverses. Inverses, inverses, inverses. Okay, so notation-wise, I kind of jumped ahead here and already used that notation right here, but this is how we notate inverses. It's like an f to the -1 power of x, but we don't say it like that. We just call it the inverse function. It does not mean reciprocal, okay? Realize that. All right, the graphs of inverse functions are symmetric to each other with respect to y equals x. And we've been talking about that as well. Compositions of inverse functions should equal x. So this is really good. This just kind of breaks down all these properties. Might take a day or two for you to understand them all, but try your best. Okay, now this here, I just want you to know on your sheet, you're given this right here. And then what I did is I created this other one. So you might want to pause the video, get a good set of notes here. But there's some points I want to make about this. So pause the video, write this down, and then join me back. Okay? Now that you're back. Did you pause the video? No, I'm just kidding. All right, so now this point right here, if we just focus on one point, that would be 0, -1. This whole concept of switching the ordered pairs around, 0, -1 turns into -1, 0. And you will see that right here. And this point is reflected in the line y equals x. So that's going to happen for every single ordered pair. All right, even the ones that don't have dots on them, like this one right here is actually right there, you know. This one right here is up here. So just realize that's the relationship between a function and its inverse. The domain of the function, like we said, turns into the range of the inverse. The range of the function turns into the domain of the inverse, very important. Second example there for you. You can look through that, try it, check what I got there. Okay, now, the composition of functions can be determined to tell if functions are inverses of each other. We said on the front page, if you want to flip to your front page, you'll see, but if we do f of g of x, we should get x. If we do g of f of x, we should get x. So let's see how this works out. This right here is take the g function, the whole g, and put it in these two places here. So a review of composites. Now we're applying composites. So x all over 2 minus x, and then x over 2 minus x. That's how we would actually start f of g of x. Okay, well that simplifies on top here to, we could make it 2x over 2 minus x on top, and then divided by, we just have x over 2 minus x, and then plus 1. And what does that mean? Well, common denominator time. So let's multiply top by 2 minus x, bottom by 2 minus x. These will cancel here. Should probably put those in parentheses, but those will cancel there. And that will leave just a 2x on top. Follow this on the bottom a little bit slower. This is going to distribute to both parts. When it comes through to this part, it's going to end up wiping that out and leaving just an x. When it goes to here, it's times 1, so we'll have plus 2 minus x. And then when we simplify, we get 2x over, x is canceled, 2, cancel, cancel, we get ourselves x. And that's what we're supposed to get. Now we have to check and see that g of f of x actually becomes x as well. So now we take this and put it in here, so that's going to be 2x all over x plus 1. I replaced this x right here with that. And then 2 minus, on the bottom, 2x over x plus 1. Okay, so simplifying this, you know, on the top and the bottom, actually we can probably just jump ahead here. Let me undo that and multiply right off the bat. So let's multiply. If I multiply the top by x plus 1, the bottom by x plus 1, these cancel here. That leaves me a 2x all over. When this distributes through to here, be careful, we have 2x plus 2. It's going to cancel off here, leaving minus 2x. So it looks a little different, but you can see we got 2x on top. These cancel. We got 2 on the bottom, and we do get to x, which confirms that these two functions are inverses of each other. We're going to be doing a lot with inverses this chapter. This is a pretty important starting point. You should now be able to do the My Math Lab assignment and really try to drive and get it like a high percent, 95% would be great by Monday.